All right, so in this video, we're going to look at the relationship between enthalpy, internal energy, heat, and work. I know that there's been quite a few questions on how do these things all work together? Why do we care about or talk about enthalpy versus change in internal energy? How does heat and work come into play here? Okay, so let's first address why we actually talk about a change in internal energy and how that actually may cause heat to be released or heat to be absorbed. Okay, so let's go ahead and say we have a reaction here. Okay, so we have A plus 2B goes to 3C. When this happens, maybe we go ahead and we look and we want to see that there is some kind of change in energy in this reaction. Well, to illustrate that, let's go ahead and say that we have kind of a reaction coordinate here and the internal energy of our overall system that we're looking at. Well, our overall internal energy changes, so we start at a place where we have our reactants, A plus 2B, and then we end up at a place where we have our products. So now our reaction occurs where we go from A and 2B up to 3C. Well, when this happens, we see that our internal energy changes. So we're going to have a difference in internal energy. Well, the first law of thermodynamics states that energy must be conserved. We can't create it, we can't destroy it. So if we're getting rid of energy or gaining energy in a reaction, that has to either go somewhere or come from somewhere. Well, the two forms that this can take is heat and work. Okay, I want to clarify one important thing about heat and work. Heat and work is not a characteristic property of a compound or an element. Okay, whereas we could say the internal energy is a characteristic property. That is why we don't say change in heat, because it's not going from a high heat to a low heat. Heat is the transfer of kinetic energy. So it's a transfer of energy already, so it's not changing. It's a transfer value. So it's already kind of built into it the idea of a change, a delta value. Okay. Same thing with work. Work is not a characteristic property of an element or compound. It is only a change in energy where we do work or have the system or work's done on the system. Okay. So now once we recognize that this is a change in internal energy, well, we can release or absorb heat, do work, or have work done on the system. We look here and we see that in this instance, our reaction is absorbing energy. Okay, so it would be endothermic, right? And so that would mean that our delta E is positive. It's absorbing energy as it goes from a lower energy to a higher energy. Well, let's say we want to actually measure this delta E value. Well, we have two components of the delta E. What we want to do is we want to remove one of those components. So if we go back and we look at how we originally defined work, we said it's the change in volume times the pressure, right, the negative of that. Well, if we make it so that our volume doesn't change, that's going to get rid of our work here, right? So if we say work equals negative P delta V, and we say delta V is 0, okay, that makes our work go away. So in order for us to get rid of our work, what we do is we set up experimental conditions where our volume doesn't change. So we say delta V is 0. There's no change in our volume. What does that do? That gets rid of that work component, right? Because now our work is 0. So now any heat that we measure in this reaction tells us about the change in internal energy, right? And we put the sub V here to show that is actually the heat transferred at constant volume, okay? Now this is something that we have to restrict. We have to set up experimental conditions that restricts volume. That's not normally how reactions happen, right? I'm breathing in and out, I'm letting reactions happen in my lungs or processes happen in my body. That is not at constant volume. It's at constant pressure, we're at atmospheric pressure. So if we look at kind of normal, quote unquote, conditions, what is constant? Well, that is where we have constant pressure. So now this work, does not equal 0. So now we have delta E equals Q plus W. Okay. But now when we're actually going to go and measure something with a reaction, we're going to probably measure the heat. It's difficult to measure the work. So we want to have some thermodynamic value that relates to the heat. Okay. That new thermodynamic value that we talk about is enthalpy. Okay. And the change in enthalpy is defined as the change in internal energy plus the pressure times the change in volume. Okay. Well, if I were going to go ahead and take this delta E and plug it in right here, okay, I'm going to write out work as it explicitly is, right? Because this would be Q plus negative P delta V. So we get delta H equals our Q plus negative P delta V plus our P delta V. That comes from the definition of enthalpy. Well, what we see, these cancel out, right? They're gone. And it ends up being that, as a consequence of this, delta H equals the heat transferred. Well, our conditions here are constant pressure, so we say Q sub P. So now we see enthalpy is another thermodynamic property of an element or compound, like internal energy. But as a consequence of the definition of it, when our enthalpy changes, this delta H, that is equal to the heat that is transferred there. And so this is why we're going to talk about enthalpy when we talk about most reactions, because most reactions are done at constant pressure. That's our normal conditions. So hopefully this clarifies a little bit about enthalpy, internal energy, heat, and work, as we're going to see all these things are interrelated to each other. So I hope to see you in class.